Hey team, I'm Maddie. Welcome to ScienceSideUp. And today we're going to be chatting with one of my friends from grad school. His name's Addison. He should jump into my Zoom meeting here in just a minute. And we're going to take a look at just a delightfully preposterous video, and I'll leave it from there. Oh, hello, Addison.
Yay,
Excellent. Excellent. I have watched this video, but you have not. So this will just be a delight for both of us. I am, to show how serious we need to take this, going to put on the fez. And before we get started, would you just quickly introduce yourself and explain why I might have asked you to go through a hurricane conspiracy video with me?
Yes, so my name is Addison Alford. I'm a PhD candidate in the School of Meteorology at the University of Oklahoma, researching tropical cyclones, how they evolve throughout their lifetime, studying features that are close into what's called the eye wall of the tropical cyclone, how those form rain bands that are just outside of the eye and lead to things like inland flooding. And I have been involved in six landfalling hurricane deployments using mobile weather radars. Have deployed into six various hurricanes, including 2 major hurricanes. So pretty well versed in hurricanes.
Excellent. Did you deploy for Dorian?
I did.
You did deploy. Okay, so this video brought to us by geoengineeringwatch.org.
Okay.
I can tell you're already excited.
I am very excited.
Yeah.
Hurricane Dorian cut a massive swath of devastation through the Bahamas. Question: was Dorian's unprecedented strength and behavior just an act of nature, or were covert climate engineering operations a major factor in the annihilation of the Bahamas?
What do you think? Were covert operations?
Well, I'm certainly not aware of any covert operations. However, I'm very, very interested to see what covert operations this person thinks that we all in the meteorological community or elsewhere, I don't know what other communities would be involved in this, but I'm certainly interested to hear their hypotheses on what technology can actually control something as large as the atmosphere.
I know.
I'm really looking forward to it.
Excellent. Okay.
Answer: Hurricane Dorian, its path, and its behavior were absolutely manipulated by climate engineering operations. Geoengineeringwatch.org recorded powerful microwave transmissions from an installation in Melbourne, Florida, repelling Hurricane Dorian from advancing further to the west.
Powerful microwave emissions from Melbourne, Florida. Well, you know, I was actually near there. Maybe it was our radars because we were pretty near Melbourne. Maybe it was our radars that did it.
Yeah. So, do you want to explain what we're looking at on the screen right now?
Yes, of course. This is typical weather radar. The previous animation was a weather radar that's in Melbourne, Florida. It's one of the WSR 88Bs. There are about 160 of these radars that are operated by the National Weather Service all over the country. This particular one happened to be the closest in terms of Dorian's approach to Florida. The one that's paused on the screen right now is located in Jacksonville. I'm not sure why that's not put, if it's the same thing, because they're all operating at the same frequency, the same microwave frequency, which sounds weird and maybe a little dangerous, but it's not. It's the same technology that cooks your food in your microwave at home. So what happens is with these radars, it sends out a pulse of energy, actually on average less than that emitted of probably a light bulb. And so it's going to, the energy is going to propagate out into the atmosphere. And as it's passing through the precipitation that's associated with Hurricane Dorian, the water molecules inside of a raindrop or ice crystals that are way up in the top of the cloud, they're going to react to that energy that's passing by. And it's going to scatter that energy. And part of that energy will come back to the radar. And that's how we can see all those nice colors on the screen. That's just the return. It's related to the returned energy that's coming back from all the raindrops inside of Hurricane Dorian. To put it in perspective for you, when we're talking about radar, it being a microwave technology, it's the same principle, and Maddie, you can probably explain it better than I can, but it's the same principle that cooks your food in a microwave. Because water is sensitive to microwave frequencies, it literally, as the energy field is passing across water molecules, it's causing them to vibrate. Vibrational energy, rotational energy, translational energy of molecules, that equals temperature. It heats up the molecules. Now, in terms of microwave, you're focusing that, a microwave in your kitchen, you're focusing that energy in a really small space and leaving the food there for quite a while until it heats up. In terms of a radar, the energy that interacts with any one raindrop is so minute that it has no effect on its temperature or anything like that. So it's not, I guess, the same principle, but it's the same general principle.
So yeah, and so I think one thing that the good people at geoengineeringwatch.org, as they slapped their logo across this publicly available data set, right? Don't understand is, okay, so those pretty bright colors you see in the bottom right-hand corner, that's like the outer rain bands of the hurricane.
Yep.
So that's a radar signal, but then the radar itself is located, I don't know if this will show up, here, whereas there's this little black circle.
That's correct.
Right? And then, so that's part of our national radar network, right? That should just be
that's operated by the National Weather Service, yes.
Yeah. And so then I think what they are mistaking this little fuzzy cloud here, the greens and the purples, I think they're mistaking that for like this huge signal propagating out. So really briefly, can you explain what that kind of noise around the radar is?
Yeah, absolutely. It's what's called, or it's what's referred to as clear air return. All this is there are water molecules. There's water inside of things like bugs, and I'm dead serious that you're probably looking at a lot of bugs or birds or things like that that are flying in the lower part of the atmosphere. Generally, they're flying along with the mean wind. So this is actually really useful for us as meteorologists, because Doppler radar doesn't just see the power return. That's what you're looking at here. Basically, you're seeing how much of anything is contained in one individual little pixel there. So you can kind of relate the information that you see on the screen to the total amount of rainfall, for example, and what you're pointing out is the outer bands. But in that fuzzy area right around the radar, that's just simply interaction with things like bugs and birds that happen to be flying along. And so that's all it is. It's not some fancy signal that causes the atmosphere to change or anything like that. It's just the radar sees, the radar can see water molecules. There's water in bugs and birds.
Yeah. So for everybody watching at home, I'm going to just direct your attention to the scale here on the right-hand side. Notice that purplish blue color is at 0, right around 0. So this signal, that's the giant signal that's supposed to be pushing the hurricane away, is 0. It's 0 energy. That's what that represents. Okay, I'm gonna press play.
Wow, 29 seconds in and we've already had this much discussion. This is amazing.
I know, right? And it just gets better. I'm so excited. I've almost figured out how to wear the fez without it falling off my head. My hair gets in the way. But for how seriously we should take this.
Yes, very serious.
Finally began to be steered northward. Other microwave transmission installations were utilized to manipulate the storm. The pulsing microwave transmission interacting with Hurricane Dorian, seen in this video, is in Jacksonville, Florida. Again, the powerful microwave transmissions have a strong steering, repelling, and moisture dispersing effect on the storm circulation when fully energized.
So this took me forever to figure out what he was saying.
Oh, he really does think ground clutter is doing all this, doesn't he?
Ground clutter is doing all of this.
Okay.
So I'm gonna sit over here and laugh, and I'm gonna let you explain what we're looking at.
Yeah. Okay, so Maddie, if you can kind of help me out here, perhaps with your cursor, why don't you point to any one of those individual radar areas where you see this kind of circular region? Yeah, go to Oklahoma City or Tulsa. Yeah, Tulsa.
Tulsa's pretty clear.
Yeah, yeah. Okay, so that's the same thing that we were looking at zoomed in Jacksonville. That's a lot of, that's just ground clutter. It's related to bugs and birds in the atmosphere. The reason that you see this kind of pulsation is because this reflectivity animation, the data that you're looking at is called radar reflectivity. The reason that it kind of pulsates across the country is because the sun is going down and coming up. So what time of the day do you see more bugs out and mosquitoes? It's at night. So the sun, I guarantee if you put a local clock on this animation, you would see that it would get dark when all of this ominous looking blue fuzzy stuff is coming out over the country. That's because the bugs are coming out. it's the simplest explanation.
No, I love that on this animation, one, there's no, this one he took off the units bar, so you can't tell what anything is, right? And there's no timestamp, so you have no idea over what period of time this is occurring. So
you also might notice in the Mountain West, you don't see a whole lot of this blue ominous goop that's on the map. And that's because a lot of the signal gets blocked by mountains in the region. So the radar signal just can't see past some of those mountains. The other thing that you might notice, if you looked at a really long animation, I'm talking days, weeks, even months animation of all these radar reflectivity images as a CONUS wide image. What you'd probably see is these large thunderstorm complexes. They're, especially during the spring and summertime months, you'll see those a lot more at night. And that's actually the subject of, and I'm probably going, if any conspiracy people start watching this, they're going to get a kick out of what I'm about to say. So there was a whole field program devoted to these thunderstorm complexes, particularly across the central Great Plains, called the Plains Elevated Convection at Night experiment, okay? So Pecan occurred in 2015. We had no less than 9 mobile radars that all were positioned in a very, very close region. And last time I checked, my job description was not to make a thunderstorm complex using the mobile radar that I was operating. It was rather to study the thunderstorm complexes that formed as a meteorological phenomenon, not because bugs came out at night. And they did, because I was out in the middle of cornfields every night, and there were a lot of bugs at night.
Excellent. Oh my God. Yes, the bugs are going to turn the hurricane. Yeah.
I can't refute that one, but...
This is my favorite video I found.
This is excellent. Now I do in a way feel bad, and we're only I think halfway through this video.
We're halfway through, yeah.
I do feel bad because this actually it's more, I guess it's more sad to me that we have people that really do believe that, you know, by looking at a map like this, that they think that we as meteorologists, or maybe they don't even blame it on us as meteorologists, someone out there is using weather radars to create bad things. I mean, I don't understand it. And perhaps that's a failure on our part perhaps we're not doing a good enough job as far as education goes. So to anyone out there that listens to this video, I invite you to come out to the National Weather Center in Norman, Oklahoma. We offer public tours Monday, Wednesday, and Friday at 1 o'clock. You can sign up online. Please come see what it is we do as a field. And please don't worry about us harming you in any way via weather radar, manipulating weather via weather radar. It's not possible.
It's really not. And I'm going to take off my not serious hat. You know, one of my favorite things about meteorology, one of the things that drew me to the field, is that literally our job is, and the mission of the National Weather Service is the preservation of life and property. So our whole job, our whole purpose in life, the whole field we have chosen to devote, you know, our youth to, is to like help protect people and their stuff. And so it does hurt my soul a little bit when people are like, but you're conspiring against us. And I'm like, we're really not. That's not our job at all. Our job is to keep you safe.
Maddie, I think you and I both agree we don't get paid enough to conspire against anyone.
Oh God, no. You have to pay me a lot more. A lot more. Yeah. Okay, all right. Non-serious hat.
Non-serious again.
Not serious. If you were here, I would give you, I need to make them, but I have actual reality goggles from the back of a Reese's.
Ooh, that would be fun, yeah.
So if, you know, you weren't 2 miles away and therefore completely unreachable because of quarantine.
Yeah.
Okay. God, we're only halfway through.
Microwave transmissions are a major component of the climate engineering operations. These transmissions are used to manipulate air masses that have been saturated with electrically conductive materials via geoengineering jet aircraft spray dispersions.
So,
I don't even know.
I know. That's a whole other video, actually, that I'm going to bother your lovely counterpart for.
Okay.
I'm going to try to bother your lovely counterpart for, because this organization has a ton of chemtrail videos.
Ah, yes.
And so that's what he's referencing. He's referencing the concept of chemtrails, which are not real and don't exist, right? No. It's just condensation. It's just water. And look forward to the video.
Great use of your time in the future to do a video on the thermodynamic reason why you actually get a trailing cloud behind an aircraft.
Yeah,
I think it'd be fantastic.
I'm gonna do that. I'm gonna do a video on why it's just condensation.
Yeah, yeah. I think it's kind of funny though that we somehow are dispersing the whatever we're supposed to be dispersing right around radar sites.
Right, specifically at the radar sites with planes.
We're really good, aren't we?
Yeah. Also, I don't know why they need to be electrically charged. That was one of the things. We're apparently dispersing electrically charged particles that at the radar sites that the radars then move, which then affect hurricanes. And if you'll check, Dorian has shown up off the coast of Florida now in the bottom right hand.
Yeah, I see that. So can I ask a question here? And maybe, I doubt you know the answer, but I'll just pose this general question. What radar out over the open Atlantic caused Dorian to form?
That's a great question. I have no idea.
I'm legitimately asking. Like,
last
time I checked, there are no radars out over the middle of the Atlantic Ocean.
Yeah, I would love to have a radar in the middle of the ocean so we could get data, so we could be better at our jobs of protecting people.
Yes,
just like
absolutely.
I'd love to have radars in the Arctic where I study, but there's none there. You can't put radars in the ocean. Turns out they sink.
Interesting. Yeah.
Okay. Nationwide grid of microwave transmission installations can clearly be seen in this video. The installations energize and de-energize depending on the objectives and agendas of the climate engineers. Dorian's approach can clearly be seen in the lower right of this video. For the record, the US government has been conducting and refining hurricane manipulation operations for over 72 years, starting with Project Cirrus in 1947, followed by Project Storm Fury. We must all consider this question. Does our government have the right to decide who is wiped out by manipulated weather systems and who is spared? Who gave them that right?
His final line, and I don't want to misquote whoever this is. The person said something to the effect of, the government doesn't have the right to decide who to save and who to not save. Dorian basically missed the United States. So if the government really is doing this, then I guess they did a good job at protecting the continental United States.
Yeah.
So I don't really see what the big deal is. Now, of course, I'm not trying to downplay the Bahamas. The Bahamas were just completely devastated by Hurricane Dorian. So perhaps that's what the person was referring to. But yeah, the continental United States was very well protected overall. Yeah, the other thing, if people really are going to, I encourage everyone, like the gentleman said, please do your research. However, I do want to point you to looking at climatological tracks before we had weather radar and see if they changed drastically from before we had weather radar, which is, as the person points out, it is a microwave phenomenon. He's not wrong about that. It is in microwave frequency. But what were the climatological tracks for hurricanes, those that we could observe? And what were they after the advent of weather radar? And I bet you won't see much difference.
Yeah. And just so everybody knows, weather data like that is free and available to the public. For all weather data is free and available to the public. You can get it from the US National Weather Service. You can get it from like the European Center. Weather is something that the scientific community has decided belongs in the public domain because it is such a matter of public safety. So you don't have, if you don't, for whatever reason, trust the National Weather Service's data, you can get data from Japan or the Met Office in the UK or the European Center for ECMWF, medium something range forecast. I use their data all the time. I just don't need information.
Medium range forecasting.
Yeah, that one.
Something like that, yeah.
Yeah, something like that. So yeah, absolutely do your research. If you don't want to believe us, but make sure you're getting data from good places, and take a look at like changes in deaths from hurricanes over the last century.
Yeah.
Because they've dropped dramatically because we're better at predicting them now than we used to be.
And not just in the US, I would probably, I don't know the exact statistics, but I would guess that worldwide, because hurricanes don't just affect the United States, hurricanes affect worldwide. So I would anticipate that deaths have generally fallen due to our ability to predict them, particularly with satellites. The advent of satellite remote sensing changed the way meteorological observations were taken and our ability to see hurricanes as they were forming out of the open ocean.
Yeah. So for the non-meteorologists in the audience, satellite became so important. So meteorology is almost divided into the pre and post satellite era. Because like we said earlier, you can't put a radar in the middle of the ocean, but you can have a satellite observe. So having satellites, so think like 1979 and forward is when we have consistent weather satellite data. Yeah, now we can see these things forming out in the middle of the ocean and have days heads up instead of hours.
Wow, what a video. I never knew we had such amazing abilities as a community to actually steer hurricanes. And just so everyone that watches this video knows, I part of my job in the School of Meteorology and part of my graduate career is to actually run mobile weather radars. I've been a lead scientist of a mobile weather radar. Same principle as what you were just seeing on the display. Slightly different operating frequency, but it's still a microwave. It's still a big microwave. But I've been doing this for 8 years now, I think, running radars off and on, or at least contributing to the deployments of mobile weather radars. And I'll just tell you that I've never seen a storm steered away from us via the radar. But sometimes we have to run away. So apparently our radar is not that good at pushing things away.
It's definitely not. You guys can check out, when you take the SmartRs out, right?
Yep, the Shared Mobile Atmospheric Research and Teaching radars. Yep.
Sweet. So if you guys are interested in the radars Addison takes out, check out my video on Taurus. I was paired with that same radar. We were just using it to look for supercells instead of looking at hurricanes. So that's the same radar. And we definitely, we couldn't push a tornado, right? Those kept coming at us.
We actually, it was really funny in the Vortex Southeast experiment. Vortex Southeast stands for the Verification for the Origins of Rotation in Tornadoes experiment. And this particular advent of the Vortex program is being conducted over multi-year study in the southeastern United States. In 2018, the two smart radars were two of the primary instruments that were used in trying to understand how we're trying to capture tornadoes in the Southeast, trying to understand how they form and evolve in different environments. And so we had just gotten Smart Radar 1, so the original Smart Radar upgraded to what's called dual polarimetric technology. And Maddie, I'll let you explain that if you want to. But
that's okay.
Anyway,
he got an upgrade. He was very excited.
Yeah, it got an upgrade. It got a nice new shiny transmitter on the back. And so what happened was almost every single deployment, I think we had 8 to 10 total deployments in that experiment. I think it was, let's call it 8 deployments. Smart Radar 1 had to abandon its site because a tornado was heading right towards the site 7 out of the 8 times that it deployed in that experiment. So again, not very good at pushing things away.
Yeah. So if anybody wants a bit of homework, you can do this all on Wikipedia, I promise. Go look up how much energy is in a hurricane.
Yep.
And then how much energy comes off of a weather radar.
Yep.
And yeah, you should be able to figure out real quick that energy to energy, right? You can't.
Yeah, that's a great way to put it.
Yeah.
You could also put that in the perspective of, I've been asked before, can a nuclear bomb disrupt a hurricane? Right. Well, in one way, perhaps, it might cause a minute ripple in a hurricane, but the energy of a hurricane is on the order of 100 to 1,000 times that of a nuclear explosion. So you need thousands of nuclear explosions to actually disrupt a hurricane, which is going to do way more damage to the Earth than it is to disrupting a hurricane, and probably more damage than the hurricane itself would have done.
Yeah.
So the answer is no. One nuclear bomb will not do that, and the energy released by a weather radar is significantly less than that of a nuclear bomb.
Addison, well, thank you so much for joining me.
You're welcome. Thanks, Maddie.
Yeah, this was super fun. I, in my quarantine, trapped in my houseness, discovered geoengineeringwatch.org, and I'm a little obsessed.
Well, now I will go. I will have to do my homework too. I've never heard of this website before, but I will have to go enlighten myself
It's
on
great.
how my job is actually to control the weather.
Yeah, I know. I never knew we could do that.
And I'm doing it all from home too right now.
Like, what class is that? Because I'm almost done with classes, and you're done with classes, and this is yet to come up.
Yeah, they haven't told me where the weather machine is yet.
So apparently that's in Alaska.
Oh, HARP.
HARP. Yeah.
I've heard that one before.
Right.
Yeah.
Yeah.
Good to see you virtually.
Yeah, good to see you virtually. All right. I'll talk to you later.
Okay, bye-bye.
Bye.
Well, team, I thought I would end this video with a couple pictures of things you should not be afraid of. Thanks for sticking around to the end here, and I will see you all later. Okay, bye, team.